Okay. Welcome to the fifth lecture, and we are supposed to have 11 such sessions, right? And today we are at the fifth session. The plan is that we will have either one or two more lectures before mid-semester, right? So this is today we are at lecture 5. So lecture 6 and 7 will be held mostly before mid-semester. Definitely lecture 6 will be before mid-semester, and maybe one more I would take if I'm not able to cover the course in the next session. If there is another lecture 7 before the mid-semester examination, I will post an announcement on the portal. Regarding the class for tomorrow, there is no class tomorrow, right? So we will not have any lecture session tomorrow. I hope that is fine. Okay, let's start for the today. We will be discussing about the interaction diagrams for today's lecture, right? Just before I start, there's a question, what about the assignment? So there are some operational issues because of which the groups for the assignments have not still been finalized. I have not even able to prepare the groups and put them onto the portal, but I think it should be done by the end of the coming week, right? So you will get the group details as well as you will get the assignment details as well. Just to remind you people, the quiz 1 has been uploaded, and it is you will be able to attempt the quiz from 10th September till 20th September, right? The quiz weightage is 3 marks. The syllabus is put there itself in one of the announcements. I've put the syllabus for the assignment as well as for the mid-semester examination. All the syllabus for each one of them has been uploaded as an announcement. Please refer to the announcements. It is there on the eLearn portal. You would also have received mails. So whenever I post an announcement, every student gets a corresponding mail, right? So please go through that. Regarding the assignments, everything will be detailed on the portal. So everything will be put there. The weightage for the assignment will be 20 marks. Okay, so let's move ahead and start today's session. So we're going to have a look at the interaction diagrams. Let's see what are interaction diagrams. Interaction diagrams show interaction among objects within a system, right? So these are behavioral diagrams, right? They are dynamic or behavioral diagrams. They do not represent a static picture of the system, but they represent a behavioral picture of the system, right? These diagrams are scenario specific, right? So as you would be remembering, we did system sequence diagrams in the previous session, right? Like your system sequence diagrams are scenario specific, in the same way your interaction diagrams are also scenario specific, right? They are designed for a particular use case scenario, right? Now the important point to understand here is that interaction diagrams are of two types. One type is the sequence diagram and the other is the communication diagram. So these are the two types of interaction diagram, sequence and communication diagram. You must be very clear that this sequence diagram is different from system sequence diagram, right? And as we move ahead, you will understand the format of drawing the sequence diagram, and then you have to be really careful while drawing each one of them. System sequence diagram has a different format, but quite similar as well to the sequence diagram, right? One quick question that I would take up from the chat is that is the collaboration and the communication diagram same? Yes, they are same. Collaboration diagram and communication diagram are same. Initially, in UML 1.0, it was named collaboration diagram, and recently, more formal name has been given as communication diagram, right? But they are same. Now, the sequence diagram and communication diagram, both of them differ in format, layout, and notations. Okay, now this is very important to understand. Let's first understand what is the difference between the two diagrams, which one to draw when, and then once we have understood the difference, then we will move ahead and understand each one of these diagrams in a more deeper way, right? Now, both of these diagrams differ in the format, layout, and notations, right? We need the interaction among the objects, right? Since both of these diagrams, they are same, only the way they are drawn is different. Only one of them has to be drawn, right? UML, okay? What is an execution specification bar? If you remember in the previous, when we drew the system sequence diagram, we had drawn only this lifeline, right? A dotted lifeline to represent the lifeline of the object. But here in this case, if you see, there is a bar that is drawn. This is called the execution specification bar, right? You can alternatively not draw this execution bar and simply draw a single dotted line to represent the lifeline, right? But even if you draw, it's not wrong. This execution bar is used to represent the focus of control, right? So you can see here that the control is there with the object A, and then it sends some message to B. B, in a way, executes this message, right, for some duration. So the focus of control is there, but at the same time, A is still executing, and then again send some message to B, and then the focus of control has gone to B, right? So, but however, if you feel this is difficult to understand, you can as well just draw a dotted lifeline, right? So this is what we understand how a sequence diagram looks like, right? So it's in a fence format. Why is it called a fence format? So it's like every object has a straight lifeline drawn like this, and it looks like there are multiple or parallel fences which are drawn, right? That is why it is called to be drawn using a fence format. Okay, I'll go more into deep with the sequence diagram. Let's just have a look on how the communication diagram is laid down, right? So your communication diagram illustrates the object interaction in a graph or a network format. Okay, so this is not in a fence format, rather than it's in the form of a graph or a network format. Okay, of course we do not represent the external actors. Now, since in this, because there is no timeline, there's no lifeline which would help us to understand that the messages layered after each other are increasing in time, right, are moving in time. Hence, as a result, in the communication diagram, we need to number the messages sequentially, right? So you can see here that the messages are numbered sequentially, right? Another thing that is important to notice here is that in the communication diagram, the links or the messages drawn are drawn as solid lines, right? The messages that are drawn from one object to the another are drawn as solid lines and not as arrows. Okay, Additionally, separate arrows are drawn to represent the direction of messages. Okay. Also, do not number the first messages, right? So this is how your communication diagrams are drawn. So they are drawn in a kind of a graph or network format, right? You can convert each sequence diagram into a communication diagram. You can convert each communication diagram into a sequence diagram, right? Both these diagrams are same in their underlying meaning, but it is only the format and the layouts of the two diagrams which is different. Okay. Now the question comes when to draw the communication diagram and when to go for the sequence diagram. The answer is, if the number of messages is too large, go for the sequence diagram. Okay. If the number of messages is too large, you should go for the sequence diagram. Reason? Because the number, assuming that the number of objects are less, you can place the objects in one page. So on the top, you can have the objects. So you have here object 1, object 2, object 3, and object 4, and you draw their lifelines, right? And then you can show the passing of messages from objects to object, and then this can proceed into pages, right? So if the number of messages is too large, the layout of the sequence diagram is more friendly, right? However, if the number of objects is very large that are to be drawn in the diagram, then the ideal diagram is to go for the communication diagram. Then in that case, the graph or the network-like format that the communication diagram has or provides for is more ideal to draw the diagram. Right? So this is what precisely you need to understand when to go for which kind of diagram. Both the diagrams are same. It is only in the layout they differ, and hence certain notations are different in both of these diagrams. Right? I'll quickly take up a few questions and then move ahead into elaborating on the notations of each one of these diagrams. Can you please show examples? Yes, I've just started. So I have couple of examples. Communication diagram is same as collaboration diagram. Yes. Messages are methods. Messages can be methods, or messages can be data that is passed from one object to the other. Right? So we'll see that also. Okay, I think I've got most of the questions, right? I'll move ahead because some of the doubts I see will be cleared when I move ahead. Okay, one quick question, and this is something that I have been saying continuously. Are system sequence diagram and sequence diagram same or different? System sequence diagram and sequence diagram are different. In system sequence diagram, we consider the whole system as black box and depict its interaction, the interaction of the system with the external actors, right? Uh, Please refer to the previous lecture. We had elaborated this on this quite a lot. So we consider the system as a black box and depict the interaction of the actor with the system. Whereas in the sequence diagram, we are depicting the interaction between the objects within the system, right? Okay. Let's move ahead. I'll keep taking some more questions as they come, but we'll move ahead with the notations, right? Okay, so let's analyze this particular sequence diagram once again and understand what it is doing. I'll pick up few notations and depict again. So this is one object of class A, right? Just to repeat, when we write colon A, it means an object of class A and it is an unnamed object. Right, so no name has been given to this object. It's an unnamed object, or it is also called as anonymous object. Right, this is another object, but it's a named object and it's called my B, and it is of type class B. Right, both these objects are within a particular system and they are interacting with each other. Now in this slide I've given you a mapping of how a sequence diagram is actually represented in code, right? So that you understand what we are drawing in the form of diagrams at a very deep level, it is going to get converted into actual code, right? So if you map this sequence diagram into an equivalent Java code, right? So this is what you will get. So there is an object of class A, right, which is existing somewhere outside, and this class A has a method do1, right? So this is the invocation of do1 method of class A, right, which is triggering this interaction, right? Now this is further invoking the method do2 on my B object, right? So here we have this. So in do1 further invokes do2 on my B object, and then it also invokes do3 on my B object, right? So this is just trying to make you understand that how you can convert a sequence diagram into actual code, right? And this is what leading us drawing the diagrams, understanding the system at very lower level, depicting it using the diagrams, and then with the idea that eventually it has to be transformed into its equivalent code, right? Okay, let's move ahead. Let's take a look at the other notations that are used in sequence diagrams, right? So this is one more notation. I'll just increase the, zoom it a little bit, okay? In case of creation of instances, right? So if there is a chance that a message sent from an object A to object B leads to creation of object B, right? Then in that case, in the sequence diagram, this newly created object has to be placed at their creation height. Okay, now this is very important to remember. So far, the diagrams that we have seen, the sequence diagrams that we have seen, we saw that we placed all the objects on top, right? This assumes that the instance of that object is existing, right? The reason why we place all the objects on top is that we assume that the instance of all these objects is existing at that time, right? But if the instance of an object is created at a later time, then that instance of the object will not be placed at the top itself, but will be placed where at their creation height, right? So as to depict that this object instance is created at a later point, right? This you can understand from this particular example. There is this register, an instance of the register class which sends a message make payment to the sales class, right? Now this sales class sends a message to create a payment object, right? So this sales class creates a payment object through the invocation of the method create cash tendered, right? So create method is called with the parameter as cash tendered, which leads to the creation of the payment object, right? So that is the reason the payment object is placed at a lower height than the rest of the objects, right? Now this is important to notice that this particular create message is a dotted line. Okay, so that's an important notation that you must pick up, is that you see that all the method calls are solid lines with solid arrows. Okay, so I'll just type it out here. So your method invocations, okay, are solid lines with solid arrows, right? And whenever a data is returned, then it is a dotted line with solid arrows, okay? But if it is a create message, then it is a dotted line with solid arrows. Okay, so these are some of the notations you need to keep in mind, right? Method invocations are solid lines with solid arrows, whichever direction they are moving, right? From one object to the other, or way back from that object to the previous object, right? So if it is a method invocation, use solid line with solid arrows. If there is a return of data, use dotted line with solid arrows. If there is a create message, use dotted line with solid arrows, right? At this point, let me just take up a few questions. Some people are saying that they're not able to see what I have typed out, right? I'll just try if I can copy paste into chat. Okay, I'll do that. I'll just rewrite it in chat. So if it is method invocation, right, then it is solid lines with solid arrows, right? If it is data returned, data or some message or any information that is returned, then it is dotted line with solid arrows. Okay, and as you can see in the slide, if it's a create message, then again it is a dotted line with solid arrows, right? So there we are with the notations. Okay, I'll just take a few questions that are scrolling. It's a create message. What's a create message? Create message is to create an instance of another object, right? Create message is a method call, but since it leads to creation of another object, which is now being added to your sequence diagram and placed at a different creation height, that is why the create message has a different notation. Okay, I think I'll move ahead. Let me move to the next slide and then take up more questions. So that was about the creation of the message. Now this is about the destruction of an object, right? So this was what we discussed somewhere sometimes back in the system sequence diagram as well, right? So there might be uh, there might be a point where execution of an method leads to the destruction of an object, right? So in that case we will use this particular kind of a construct wherein we show that a destruction message has been sent to destroy a particular object. And to mark the end of lifeline of an object, we use a big cross to represent that this is the end of lifeline of that particular object. The destroy, either there might be a call, method call, which is destroy and with some parameters, or if it is not a method call, you want to represent it using an explicit destruction message, then you might use the stereotyped message, which is the word destroy enclosed in guillemets to represent that a message has been sent to destroy the payment object, right? Message is actually always a method invocation which is leading to the destruction of an object, but you can represent it using alternate notations, right? So you can either simply write the stereotype destroy or write the method call, right? The only importance of using a stereotype tag is to specify that this particular message will lead to the destruction of this particular object, right? And then we would say that we will use a big cross to depict the end of the lifeline of that object. Okay. Okay, let's see further more notations. So in a sequence diagram, an object can send a message to itself as well, right? So this is called a message to a self, or this. This is illustrated in this following way. So you can see here that a clear message is being sent to by the register object to itself, right? So this is, it's kind of a loop to itself. You can omit drawing the execution specification bar and simply have a lifeline and a looping method to it, right? Another thing to notice here is that you would find that in these diagrams, whatever whatever information is written on the top of the message, it is not very clear whether it's a data that is being that is there or whether it's a method call, right? It is only through the notation that we are able to pick up, because it's a solid line with a solid arrow, that we understand that this is a method call, right? But to be more clear, when you yourself draw sequence diagram, it's always a good idea to write do X and put brackets in order to make it understandable that this is a method invocation, right? So it becomes more clear to yourself and even to the person who is evaluating the answer script, that you are clear that this is a method invocation, right? Okay, I'll take up few more questions that are coming up. What is clear method? Some method that is that particular object is invoking on itself. Nothing like that. It's no particular method. Okay, I think I've captured most of it. Okay, let me go to the next slide and I'll continue taking more questions. Now let's understand there is something called as diagram frames. Okay, your sequence diagram supports an additional notation which is in the form of diagram frames. These diagram frames are used to support conditional and looping constructs. right? And in this case, we're going to see three of these constructs. The frames or the diagram frames are regions or fragments of the diagram, and we provide an operator or a label in order to classify those frames, right? So these frames consist of an operator or label such as a loop or a guard condition, right? The guard clause should be placed over the lifeline to which it belongs to, right? I'll move ahead as we take more examples, then you understand what is the diagram frames. So there are three kind of diagram frames that we would be looking into this particular course: the alternate diagram frame, the loop diagram frame, and the optional diagram frame. Okay, I have one slide for each of these frames, so let's move ahead and understand each one of them. Starting with the loop frame, right? I hope you remember this frame. We've seen this before also, right? This is the way you depict a loop in the system sequence diagram as well, right? The only difference there was instead of B, we had system here, and instead of A here, we had an actor here, right? So similar notation of the frame for representing the loop is also available in the sequence diagram, right? The same notation that we used in the system sequence diagram for representing loops is also used in the sequence diagram, right? So this is the frame label, which is called the loop, and which is the loop in this case because we are creating a loop frame. And this is the guard condition, which is written on the top of the lifeline of the particular object, right? Okay, so this represents a loop frame. Okay, let's move ahead. So this was one. Going to the next one, the conditional messages. Okay, now for the conditional messages we have the opt frame, right? This is my opt frame. Instead of writing loop here, we write opt frame, opt here, and this is equivalent to if then construct. Okay, this is equivalent to if then construct, right? So this is my opt frame. What we are doing in the opt frame, we are writing the condition here, okay, and we have written color equal to red. If this condition is true, then only this calculate message will be executed or will be sent, right? Only if this condition is true will this calculate message will be sent. So this is an opt frame or an optional frame. Okay, so there's a quick question that has come up, is that how do we represent the else condition, right? So that we have the alt frame, right? Let's see the alt one. I'll take you to the next slide. So this is the alt frame. This is equivalent to if then else, right? Okay, so here we write alt here, okay, and then we specify the condition which when will be true, calculate message will be sent, else this calculate message will be sent. Okay, and then you can see here that there is a dotted line, a dashed line, sorry, not dotted, but a dashed line, which is representing, which is partitioning the two frames, right? So there is a then portion and there is a else portion, and your dashed line is partitioning the two portions. Okay, fine. I think these notations are clear to you, and that is why I see so many questions flowing in about nesting of these frames, right? So I've got this in the next slide. You can nest these frames as you desire, right? There can be any amount of nesting that can be done as the condition would be. Okay, so you can put a loop inside an opt, you can have a loop inside an alt, you can have opt inside loops. Any such condition is possible, right? Okay, there is question. I'll just take a few more questions. So they are saying the question is that what about switch construct? Okay, so there is no specific frame operator for a switch construct. If you want to implement a switch construct, convert it into an if then else, right? Every switch construct can be converted into an if then else, right? And once you have if then else, then implemented using ALT construct, right? So then that way switch can be done. Okay, I think there are no more notations that I have to introduce at this point of time. So I'll take a few more questions and then we'll do an exercise. The question says, can you please tell every diagram using code? I leave that to you. Please convert every diagram to code. Okay, and that can be definitely done. Okay, so we can, the question is about the switch, so convert it into an if then else and nested ifs and create one. Solid process bar is missing on the object lifeline. I've told you this, that this is an optional execution specification bar that has been introduced in UML 2. However, you need not bother while drawing the same even in the examination. Just go for a simple dotted lifeline. Can we create object calls in loop frame? Yes, you can. There is no restriction on that. Can there be again a condition inside the else? Yes, that nesting is possible. Okay, I think I've got most of the questions. You can continue to send questions as we take up the next example. Okay, so let us take up this exercise. The exercise says, for the snakes and ladders case study, draw the sequence diagram for roll the dice scenario, right? So there is this scenario where there is a request to roll the dice, right? Let's understand this particular sequence diagram and then you can ask more questions. So I've got the solution here for roll the dice. Okay, is it visible? It's quite small. Okay, right? This is roll the dice scenario, right? There is a outside, there's a message, an initial message which comes to the game controller, right? Okay, so we have two objects here which are the objects of my snakes and ladder system. The one is the game controller and the other is the dice, right? My game controller is the one to which all the external messages are being passed to. Now this first message or the external message that comes from an external actor is also called as found message. Okay, I have not mentioned in the slide, but it's there in the book. You can see the first message that comes in is called a found message. You need not represent the actor who has sent this found message. Okay, at some places you might even find a small filled circle drawn on the starting point of the found message, right? So this is the message which actually invokes the particular scenario or sequence of interactions among the objects, right? So let's move ahead and understand what's happening. So a roll dice invocation has happened, right? And this message has come to the game controller. Now, what is the next step? The game controller invokes the roll message of the dice object, right? Some execution is done, and then the dice object returns the face value of the dice after rolling, right? So just try and visualize what the code would be there in the dice object, right? So dice would be, once you would say roll dice, it would be actually generating a random number between 1 to 6, right? And returning the face value of the one of the faces. That means the value which it has generated in random, right? Okay, a few questions I will take up now. Where does the game controller and the dice come from, right? Now these objects, they have been picked up from the domain model, right? So domain model was the model that was drawn before drawing the sequence diagram. So from the domain model, we know that there is a game controller and there is a dice object or a domain concept that exists in my snakes and ladders case study, right? The roll dice message, it comes to the game controller, right? The player and the game owner both directly interact with the game controller, and it is the game controller which is the controller class. I will not use the word class. The game controller is the main domain object which is responsible for controlling the entire process of the snakes and ladders system, right? Okay, so that is why I got a game controller and dice, right? I'll take a few more questions. The diagram is a representation of one-time action. It is not necessary that a loop and a condition needs to be added. You will add a loop or a condition only if required, right? In this case, if you see, there is no loop and there is no condition, right? Why no board class? There is no role of board class in the roll dice scenario, right? If you see the roll dice scenario, it doesn't use anywhere the board concept, right? The game controller will simply invoke the dice and get the value of the random number that is generated between 1 and 6. The messages are scrolling so fast, I'm not able to pick them up. Okay. I'll take up an example of nested frames. Okay, I think I have answered most of the questions. I'll give you an example of opt and nested frames as we move ahead. Okay, so what I'll do, I'll just put up the next question, the next exercise that we have, and leave on to you. Just take 5 minutes break, and all of you please, along with the break, even try and solve this particular uh, sequence diagram, draw the sequence diagram. So the sequence diagram is for moving a coin on the boat. Okay, so you have to draw a sequence diagram for moving a coin on the boat. We'll just take 5 minutes break here, and we'll come back and solve this sequence diagram.